hopefully encourage you us. Subject. All right, so yesterday's keynote, right? We all started with the concept that 75% of the cost of inferencing on AI is reduced if you bring it on-prem, right? So Michael Bell said 80% of people, they're bringing day trading from the cloud, right? So what does that mean? That means that this, which is what the way that you're used to using AI, like ChatGPT, this is going to be good for some things, but it's not good for everything because it's too expensive, right? That's because we're basically doing it this way, right? We're going and putting everything in the cloud and we're kind of, right? So if you guys have tried like some of the newer ones, there's an interesting thing that happens if you use like Bing, because what they'll do is they'll go and they'll find more sources, right? And immediately, as soon as that happens, the first thing you should be thinking about, of course, is how do I use this for my business, right? Because if I simply replace this data with my business, this should be something that would be more useful, right? So in reality, what this talk is about, albeit obviously something happened with the slide, is how do I apply this LLM tech to my own data set? And the problem with doing that is that my own data set is quite large and it's always changing. And it's probably something that I want to make sure kind of stays under my control, right? To understand what's going on here, we have to think about what computers are actually doing for this most of the time. And it's actually really quite simple. We're just retrieving information, right? So if I go into a database and I ask a very simple question, for example, how many of a certain widget exists in the warehouse, right? It does that very quickly. But if I want to go and do something slightly more complicated, then I end up over here, because what's going on is that I'm going and doing processing before the user sees it, right? So if I have a more complicated question like this, which is I want to generate a report or something, right? Then obviously that's going to cost me. So over time, what things cost kind of changes, and that's kind of what Moore's law is about. And nowadays, we can do things like this kind of easily, right? We can say, all right, well, we're going to do analysis over 10 years. And that might only take an hour on CPU. So why does this matter? Why it matters is because if you add a whole bunch of GPUs to this, then we obviously have changed what can happen here. Now, when that happens, the problem is our mindset is that because we spent our entire, well, not the entire, but maybe the last 2 years or so, year and change doing ChatGPT, we only like to think about these. We like to think about these things because they're sexy, right? Because it's like, oh, can I make like a 1,000 word essay? And then it's like, yeah, I can. Oh, can I explain it like an 8-year-old? Oh, well, yeah, I can. But the thing that I think we forget is that these things, these are very rarely the questions that we actually ask at a business. And so when we have all of these things on the right-hand side of the spectrum of possible complication, the question is, what's going on over here? And sadly, the answer to this is a whole lot of nothing. Because if I go to OpenAI and I ask them, how do I apply OpenAI to my data set? Do you know what they do? They say, well, it's real simple. You take your data and you upload it through my cloud, and then you do something like this. You ask your data custodian, oh, Mr. CISSP, please make a copy of all my proprietary data and send it to somebody else. Now, this is obviously a problem. Aside from the fact that this is a problem because you've just done this, there's actually a whole bunch of other things going on. This data has role-based access control. It's microsecond, right? And so you have to copy all of that too, which obviously doesn't exist in a lot of applications. And after you copy that, well, then you're going to go crank away at all these things. And where is this? This is on the right-hand side of that spectrum of possible computation. Now, when you do that and you add another application like LinkedIn, then it looks something like this. And this is the current gold standard. If I walk around anywhere in San Jose, I am at least on any given day, if I just walk down University Boulevard in Palo Alto, I will probably walk past 5 dudes that have each gotten $5 million in VC to build this. See? I'm not kidding. There's $1 billion out there, and it's all doing exactly the same thing. Building a very thin layer on top of this. And the problem with this is that this focuses on the right-hand side of that spectrum of possible computation, which is extraordinarily expensive. How much does ChatGPT cost, Steve? Who has a subscription? None of you? No one has a subscription. I know at least some of you do. It's about $20 a month for a consumer, okay? But that's for a consumer. Most of us here have come to this conference, we're buying servers, we're buying storage. This is a B2B play, right? You know how much it costs for a business? It's expensive. something like this for every single query. Now they do call it chat, right? Which means that when you want to use this thing, do you just ask it once? Now, you go back and forth a few times, right? So this hacks up quick. Another way to put this in perspective of how much this costs. If I take 100 of these queries, that is approximately 1 kilowatt hour. 1 kilowatt hour is what it takes to move a Tesla, which weighs 4,000 to 5,000 pounds, 3.25 miles. All I had to do was ask ChatGPT 100 things. Because mind you, if you go and do that back and forth and you do chat, right, that could be like maybe 12 sessions. So the expense of this really cannot be overstated. And the problem is, if you take these very simple questions and you apply these questions to that monstrous amount of hardware, what you're going to do is wasteful. So the question is, how can you do better? Because these simple questions, right? And you also have a continuously changing proprietary data set, and you also have a very large one. How can you do better? So here's an example of something that we've done, and I've been personally working on for the last year and change. If I take a Dell XR7620, and I load that with either an L40, an H100, or one of these combined GPU, CPU cards, right? These start at a fairly reasonable price, like maybe $2,000, $3,000, and it goes all the way up, of course, to but if I put that in there, and I run a piece of software on this, and the most important thing is I have an infrastructure to update this on a regular basis, then it turns out that what I can do is I can do what I need for my business without that massive infrastructure on the right-hand side. I can basically leverage, remember that slide where I was showing the spectrum of computation, there was nothing going on. And the way we can do that, right, is by loading this particular piece of software. And when you do that, right, you solve a whole bunch of problems. First of all, you solve the data privacy problem. Why do you solve that problem? Because you haven't actually moved the data someplace else. More importantly, the RBAC, the microsegmentation, all of those kinds of things that, with those respective restrictions, are built into the box. Second, data is always concrete. Can you imagine, like, taking an electronic medical one, which has your labs, right? They drew your blood, right? And now every single time they do a lab or any kind of telemetry, I need to synchronize that with the cloud. Does that sound like that's going to work very well? Because, after all, I think every single person in this audience has had a failure of that kind, right? Where the data desync. Hell, if you play a video game, which if you haven't seen the Dell Alien Bear thing, right? Just go there and sit there and watch for 5 minutes. They play the video game for 5 minutes and it desyncs. If that's going to happen for that, what's going to happen? Well, I'm not going to be able to deal with this, right? And of course, there's the cost, right? We said that it's about $4 right, the session, and then that doesn't count the storage cost. If I take 20 terabytes of data and I put it at rest, unencrypted, which is a terrible idea. Let's say I did that. That costs $2,100 in simple storage centers per month, recurring. So that means that if I did nothing with that 20 terabytes of data, I would be out $25,000 a year. Nothing. That's unencrypted. If you encrypt that data, then you got to pay for the decrypt process, which of course drives that cost steep higher. So these kinds of problems, right, are the problems we're trying to solve. We're trying to make it so that normal people can run LLM tech, like the GPT types, and we want to make it so that you can hook up your applications to that without breaking the bank, right? We want to make it so that everybody can have access to that. And we want to be able to draw the data that we have from the network and things like that in. So as a net result of this, right, we're going to have the situation where the data is distributed, which of course immediately brings the question of, well, how do I synchronize the data that's distributed? Well, we have a piece of software like that. And this is not new software, by the way. We're just applying the same piece of software. If you want to see this demo, I'll say it again, come to our booth. But we've been doing this for like 15 years. So same thing, we can of course build a private cloud version, centralized GPUs, or of course the most interesting thing is you can have a hybrid approach, right? Where you kind of centralize just the GPU power because the LLMs can live here, but you can do the retrieval augmented generation in the distributed map. And if you do that, then that gives you the best value. Because this network here, with these users here, be it sales data, electronic medical records, or the networking data that's coming out of this, is going to write here. It's not going to go off to the cloud. It's not going to go off the front top. It's going to live here. And because it leaves here, I can run retrieval augmented generation on this with a remote LLM, which that is a very small payload. And that's how I can get the ultimate kind of benefit of this approach, of this distributed approach. So what can I apply this to? Let's talk about this. This is a multiple dwelling unit scenario, right? You've all driven by these, right? Because 60% of the new construction in the United States is this stuff, right? And it's kind of weird, I know, because a lot of us, we live in single family homes. And my biggest problem when I talk about this stuff is oddly that most of the people that make decisions about this are so wealthy, they would never imagine living, right? But this is most of America. And when this is most of America, well, you got to figure, how do you support this? Well, you support this with these people and these people and these people. This community, in the leasing office alone, the median MDU has 5 full-time employees. That's not including maintenance. That's just the lease. That's cheap. And so if you have that many people going on, the question is, how can I do better? Because most of the questions that people ask are about community events, maintenance schedules, regulations, and neighborhood tips. Because most of the questions they ask are, what's the trash schedule? And when you have to have people answering the trash schedule, what's the trash schedule? Well, that's a problem. So then you think to yourself, well, I can automate that somehow by moving the person that answers the phone to an offshore thing. But that doesn't really work in this world. Because the whole point of renting this place is that you can talk to people. But as we know, Generation Z, especially coming up, they would rather talk to computers. So if this is what's going on, then our thought is, well, and this is an actual screenshot, by the way, of an actual deep look. Come to our booth and see this. And you can ask, well, when is track for that? And it'll tell you exactly what it is. Why? Because we loaded the PDF with the trash schedule into the system. And that system is local to that MDU. And if there's 1,000 MDUs, which we presently serve something like the DAR software at 1,800, that has to roll this out, will be 1,800 different trash schedules. And every single place will have its one. Now, the interesting thing, of course, is not just that, but when you add a Wi-Fi 7 network from Ruckus Networks with ICX switches to this, then you can do really crazy stuff. Because the static stuff, right, I get that, right? I'm gonna go load some data from some PDF, I get that. But here, what I can do is because I have this Wi-Fi 7 network with Ruckus Networks deployed across the entire property, I can have end user locations of every single device on this network. I can have radiometric telemetry, client metrics, I can have gateway KPIs, I can have all of this data coming in and feeding this. I could not do this in a cloud solution. Because if I did that, even if I could do that, it would cost me so much money, I would never do it. So I bring all of this data local to this Dell XR7620 with L40S on board with it, and then I can do this. I can start asking simple questions, like I showed before, like what is a target trash pickup. I can start adding more complicated questions. I can ask questions which they call to an API. Why? Because I showed you on the side before, right? This architecture supports proprietary applications. We'll go and talk to what we've got and go and pull in this data. I can ask questions like, is the constants in the check? How does that work? By hitting another API. But here's where it gets really fun. Because as I move to the right-hand side of this spectrum of Postic application, now I can ask a question like this. And if I live at this MDU, I would really like to know when there is the least amount of people in the gym. And this system can tell you that. Why can it tell you that? It can tell you that because it's ingested client metrics, radio metrics, and client locations, stored that into a unified database, built that into a RAG on-prem, and it's going to execute this on L40 that is on the prem. Right? So this is a completely different way of doing this. It completely obviates any kind of problems with personally identifiable information, and this is where we think the future of this is going. As we roll this out to more MDUs, we expect more and more fun questions like this to be asked. For example, I could ask a question if in the co-working space, if there's anything free. Or I could ask when is the busiest pool, when is the busiest time at the pool? And usually, a person like me is like, no way, I would ask this question because I want the pool myself. But do you know, actually, it turns out, having deployed thousands of MDUs and talked to hundreds of policing officers, people actually ask this question because they want to go party, believe it. Because they want to go and have a barbecue with other people. And so this is an important part of how they build it. There's another fun question here, which is that whether or not the valet has picked it up trash today. Why? Because if I go and I take my trash and I put it outside for the valet, and the valet has already picked it up, I get a fine. That's the community rules. Like by having a system like this, I can ask the LLM with that. And I guarantee you, this is exactly the kind of question that the leasing office hates to answer. And they may not even be. Because that leasing office may only be open from 9 a.m. to 6 p.m. Anyway, so the thought is that we can do all of this, bring it together on Dell platforms, like it's networking. Come see us at our booth. We're demoing Wi-Fi 7 Edge LLM. Thank you for your attention.
Fantastic. Let's give it up for Simon. That was great. I do have one more task for you, though, Simon. Does everyone have their raffle ticket?
Yeah.
Wonderful. Okay, let's make